Dear students, very good morning. It is Professor Subramanya Bhagavat, your computer science coordinator. Welcome back to discrete mathematical structure. Today I am going to explain you about very important concept, that's converse, inverse and contrapositive and their relations. Suppose an equation, or what I call a statement, P implies Q. Hmm? Consider statement P implies Q. Uh, if you write Q implies P, that is called converse of P implies Q. If you write, wait for 1 second, I will tell you. You have taken P implies Q, okay? If you write this one as a Q implies P, this Q implies P, okay? That is called converse of P implies Q. Q implies P is a converse of P implies Q, okay? Next is, okay, you have taken statement P implies Q, where if you insert this one, okay, negation of P implies negation of Q, or inverse of P implies inverse of Q, that is nothing but inverse of P implies Q. Next one is suppose I'll write entirely different. I'll write this statement P implies Q. I'll write it Q implies P. That is yeah, that is nothing but converse. Again here negation of Q implies negation of P. If I make this is contrapositive of P implies Q. So we three important things. Wait for 1 second. Wait. This rules of inferences, remaining things, next class I am going to cover that things also. Yeah, here P implies Q, okay. Given statement is P implies Q. If I write Q implies P, that is called converse of P implies Q. If I write negation of P implies negation of Q, that is nothing but a inverse of P implies Q. If I write negation of Q implies negation of P, that is called contrapositive of P implies Q. Okay. With example through we will study. Suppose, yeah, P is a statement, it says 2 is an integer. Q is another statement that says 9 is multiple of 3. How do I write P implies Q? How to write P implies Q? P is what? 2 is an integer. Q is what? 9 is a multiple of 3. P implies Q says if 2 is an integer, then 9 is a multiple of 3. Then how to write this statement as okay? Yeah, Q implies P. What is Q? This is Q. Okay, this is P. So when I write these things, first Q means 9 is if 9 is multiple of 3, then P. Then P is what? 2 is an integer. That is called Q implies P. Now my question: negation of P implies negation of P Q. How do you write negation of P implies negation of Q? P is what? 2 is an integer. Negation of P is if 2 is not an integer. Then negation of Q is 9 is multiple of 3. 9 is not multiple of 3. Okay. So, wait. Negation of P implies negation of Q. What I write? What is P? 2 is an integer. Negation of P means 2 is not an integer. You write it 2 is not an integer. If 2 is not an integer, then 9 is not a multiple of 3. Then, okay, negation of Q implies negation of P. How do you write? What is Q? 9 is a multiple of 3 is Q. What is negation of Q? 9 is not a multiple of 3. Then what? Then QP is what? 2 is an integer. Negation of P is 2 is not an integer. Like this way, you can write a statements very easily. Now, we will check it these things, truth tables. Okay. Carefully observe it. Wait for 1 second. If you observe here, yeah, P and Q I am writing. P is 0, 0, 0, 1, 1, 0, 1, 1. Negation of P, when P is 0, this is 1. When P is 0, the negation of P is 1. When P is 1, negation of P is 0. When P is 1, negation of P is 0. Then negation of Q. Q is 0, negation of Q is 1. Q is 1, negation of Q is 0. Q is 0, negation of Q is 1. Q is 1, negation of Q is 0. Okay. Now P implies Q. When P is 1, Q is 0, then only false 0. False. Otherwise, it's 1. Then Q implies P. Q implies P. When Q is 1, P is 0, then only 0. Otherwise, it is 1. Okay. Now, negation of P implies negation of Q. When p first one is 1, second one is 0, then only 0, otherwise 1 it is. Okay, then negation of this one, negation of q implies negation of p. First one is 1, second one is 0, 0, then all these things 1. Okay, carefully dear students, carefully dear students, all of you are observing this, right? Carefully watch that things, carefully watch. Okay, what is the relationship between these three? Okay, is there any two columns? Carefully watch that thing, simply watch that things. All of you are here, right? Or this q implies p column and negation of p implies negation of q column. Watch this. First one is same, second one is same, third one is same, fourth one is same, no doubt at all. So we understood that, so we understand that this q implies p is logically equivalent to minus p implies minus q. Then if you observe the other relations, observe this p implies q and this minus q implies minus p. First one is 1, first one is 1. Second one is 1, second one is 1. Third one is 0, third one is 0. Fourth one is 1, fourth one is 1. So we no doubt this p implies q is logically equivalent to q implies p. So we came to the conclusion. First one conditional, that's a p implies q is okay, and its contrapositive minus q implies p are logically equivalent. P implies q and minus q implies this one. Wait, p implies q. P implies q and wait. P implies q is equivalent to what? P implies q is equivalent to minus q implies minus p. That is nothing but okay. This is okay. Contra conditional. P implies q is conditional, equivalent to contrapositive minus q implies p. That is a minus q implies minus p. That's a contrapositive. Both are same. Both are same. Next one means logical equivalent. Next one, converse and inverse are conditionally converse or inverse are logically equivalent. Converse is what? Q implies p. Inverse is what? Minus p implies q. Okay, this wait for a second. Do you see here? This you see here. This is same. This is same. Last one is same. Fourth one is same. So no doubt. Okay, converse and inverse of this one, converse, okay, and inverse are exact logically equivalent. Logically equivalent. So today's class, okay, what we have studied? Today's class we have studied converse, inverse, and contrapositive. Then come to last class, next class. Because previous class, what I had explained you. Previous class I have explained you about modus pons. Am I right? Modus pons. They are okay. Wait for 1 second. Yeah, modus pons. P implies Q, then P, and P, then Q. That is called modus pons. Then modus tollens. What is modus tollens? P implies Q. Okay, wait. Modus tollens says P implies Q and negation of Q, then minus P. How do you prove that? What are the assumptions? These two are assumptions. P implies Q and negation of Q is assumptions. Assumptions are always true. When we say that okay, minus Q is true means Q should be false. Q should be false. When Q should be false, okay, this is true. Assumption is true. P may be true or false. So minus P should be P may be always false. So minus P should be true. So it has proven. It has proven. Am I right? Yeah. Wait. So we understood that. Okay, wait. We'll change the pen. Wait. Assumptions P implies Q true. Okay, and minus Q is true. Minus Q is true means Q should be false. So this should be false means P always should be true, because true, then it is false, then only true. So P should be false means negation of P should be false means negation of P should be true. So no doubt, okay, this is correct. Modulus of Tolan is correct. Wait. Slowly observe that things. So you understand these things. So we have clearly understood these things. Next one, okay. Hypothetical, okay. Select. This also I will explain in next class. So this class, yeah, first one, modus ponens. This types of inference rules, modus ponens and modus tollens we have studied. Modus ponens, once again I tell you, these assumptions always true. They have given this P is true, P implies Q, this is also true. So P is true, all this is true. So this should be true. So then only it works. If it is false, it's not false. Then modus tollens, this one, this assumption is true, and this assumption is also true, means Q should be false. When Q should be false, okay, when Q should be false, suppose P is true, means answer will be false. So P should be false, then only answer will be true. So when P is false, it's a negation of P should be true. So next class will continue. Wish you all the very best and study well.